We're going to start with 2-5, solving equations involving absolute value. So let's look at this. So the first thing, the whole point is to get the absolute value bars all by themselves. And so you have to undo addition or subtraction of the numbers that are on the outside of the absolute value first, and then undo the multiplication and division of the things on the outside of the the absolute values first. Now, is there a solution or not? Remember, the absolute value is the distance from 0, and distance needs to be positive. So if it equals a negative number, then the answer is no solution. You can't do that problem because there's no distance that's negative. If it's a whole number, that meaning it's a positive number or 0, then you keep going. So then you take off the absolute value bars, you make two equations. One is going to equal a positive number and one a negative number, and then you solve it. So if I look right here, down here, there's nothing to add, subtract that are on the outside of the absolute values. So then I look, is this number positive or negative? It is positive, so I'm going to keep going. Then it says to make two equations. So I'm going to make an equation over here, and I'm going to make an equation over here. My first equation is going to be y plus 2 equals 4. It's the exact same thing as we have up here, except for we've gotten rid of the absolute value bars. Then I'm going to do the opposite of 4, so y plus 2. That part didn't change. The only part that's changing is the negative 4. The reason being is the distance from 0 is 4, right? So on the positive end and on the negative end. Okay? So here we go. We solve it. So I subtract 2 from both sides. I get y equals 2. And then I subtract it. I do this side. And I get y equals negative 6. So my answers to this are y equals 2 and y equals negative 6. Okay? So over here, as I'm looking at it, there's nothing on the outside of the absolute value bars that I need to do. So I'm going to take the equation without the absolute value bars, and then I'm going to write the what's inside of the absolute value bars, set it equal to the opposite of 8. And I'm going to solve this, just like we've been solving all the other problems that we've been doing. Okay, and over here, I'm going to subtract. Divide by 2, t equals negative 8. Okay? Again, we're going to do the same thing over here. I'm going to look at it. I'm going to say, is this number positive? No, it is not positive. That means that this answer is no solution. I didn't even have to do anything. Okay, again, I'm going to come here. Is this number positive? It is positive, so I'm going to write k plus 9 equals 2, and k plus 9 equals negative 2. And I'm going to solve that. So I'm going to subtract 9 from both sides, get k equals negative 7. Subtract 9 from both sides, k equals negative 11. This one, look at this. It's positive, so I'm going to keep going. K minus 9 equals 2. And k minus 9 equals negative 2. So I'm going to add 9 to both sides and get k equals 11. Add 9. and get k equals 7. That was a horrible 7. Okay, let's do this one. It's equal to a positive number, so I take 2x equals 12 and 2x equals negative 12. Divide by 2, get x equals 6. Divide by 2, x equals negative 6. Okay, so now we're going to add more things to it. So right now, if you look at this problem, it has addition or subtraction on the outside of the set of absolute value bars. We need to undo that before we can do anything else. So first things first, I have to add 4 to both sides. I get the absolute value of 2x equals 18. Okay, is 18 positive? It is, so I'm going to make 2 equations. 2x equals 18 and 2x equals negative 18. Divide by 2, x equals 9, and, divide by 2, x equals negative 9. Okay, next. How about I want to go to the harder ones. Do we not have any other harder ones? I want to go to this one. Right here. So right now I have multiplication on the outside. So I need to get rid of that first. So I'm going to divide by 2 on both sides. And I'm going to get the absolute value of negative x equals 12. That's a positive number. So I'm going to come over here and I'm going to write negative 3x equals 12. And negative 3x equals negative 12. I divide by negative 3, and I get x equals negative 4. Divide by negative 3, and x equals positive 4. They are not always opposites of each other. Okay, so let's look at this one. This one has division going on first. So I'm going to multiply both sides by 2 first. I'm going to get the absolute value of n plus 1 equals 28. This number is positive, so I'm going to write n plus 1 equals 28. And, I'm going to do this one. N plus 1 equals negative 28. Subtract 1, get n equals 27. And subtract 1, n equals negative 29. Okay. This one, I need to get the absolute value by itself. This is positive, so I set each side equal x over 7 equal to the positive 1. And x over 7 equals the negative 1. Solve each one of those, multiply by 7. X equal, I don't know why I did that. X equals 7 and multiply by 7. X equals negative 7. So on this one, it's the same type of deal. Get rid of my fraction. So I'm going to have 3 absolute value, negative 9 plus v equals 24. Divide both sides by 3. Get negative 9 plus v equals 8. Okay, that's a positive number. So I split them apart. So I get negative 9 plus v equals 8. And negative 9 plus v equals negative 8. Add 9. V equals 17. And 9, b equals 1.